All right, so today we're going to learn our last lesson of chapter 3. So finally we made it. So let's put our name and date at the top here. We're going to learn solving systems of equations. So we practiced graphing them yesterday, but using algebra to solve them. So we have our last vocab word here on slide 2. In the previous lesson, where we learned by graphing, you estimated the solution of a system by graphing. Substitution is an algebraic model that can be used to find the exact solution. So let's say the numbers are really ugly, they're not very pretty, they're not easy to graph. Solving them algebraically might be a little easier. We'll be plugging or substituting one equation into the other. Sometimes this just means we set them equal to each other. The answers are going to be written as ordered pairs. We've been doing that. Try to notice what form these equations are in. If they're in slope-intercept form, y equals mx plus b. That's ideal. That one's really nice. Standard form is that ax plus by equals c. This one's a little bit trickier because you have to solve for either the x or the y before you can plug it in. So that one's a little bit trickier. Moving on to slide 3. It says, notice that both equations are solved for y. This is really nice. So y is equal to something. So it says solve the systems algebraically. Well, y is equal to x plus 4, and y is also equal to 2. So what I can do with this, y is 2. So I can just plug that in right here. 2 is equal to x plus 4. To get x by itself, I would subtract 4. And I would get negative 2 equals x. My answer should be an ordered pair. The x value is negative 2. And the y value just comes from our equation up at the top, 2. All done. Those are nice numbers, not so bad to graph, but we're just practicing here if we had some ugly numbers. In letter B, we have y equals x plus or minus 6 and y equals 3x. So if y is equal to y, then we're just set these two things equal to each other. So 3x goes in here, so 3x is equal to x minus 6 because y is 3x, so you can just rewrite it right there. Getting all the x's on the left-hand side. So I have 3x minus x is 2x equals negative 6. Divide by 2. We get x equals negative 3. Well then, to find what y is equal to, I need to replace my x up here. So I'm going to take my x and plug it in for y. So y is equal to 3 times x, or negative 3. Y is equal to negative 9. So my ordered pair would be negative 3, negative 9. One solution. Okay, so let's move on to, sometimes we're going to see things that are not both y equals or slope-intercept form. So it says slope-intercept form and standard forms. Sometimes one or both equations are written in standard form. When solving a system by substitution, one of the equations should be solved for x or y. You can solve it for x, you can solve it for y, it doesn't matter, but something needs to, we need to have the value of one of them. Gives us a nice little hint here. When you replace a variable with an expression, if you write the expression inside parentheses, that will help you apply the distributive property correctly. And I have a note here. You cannot substitute if both equations are in standard form. One equation must be in slope-intercept form, or both of them. You can solve them both. And then substituted back into the standard form. So let's look back here. So slide 5. We see one of them is in slope-intercept form, and the other one is in standard form. We just can't take this one and set it equal to this because they're not both y. So either we have to solve this one to be y equals and then set them equal to each other, or because we know what y is, we can replace this y. So I'm just going to take this y out and replace what it's worth. So I know that 8x plus 4 times y, but y is 3x plus 8, has to be equal to 12. So I need to distribute my 4. I'm going to bring down my 8x plus 4 times 3 is 12x plus 4 times 8 is 32. Bring my equal down to 12. So combining like terms, I would get 20x plus 32 equals 12. Getting the x closer to being by itself, I would subtract the 32. And I would get 20x equals negative 20. Dividing both sides by 20, I get x equals negative 1. I remember that my answer has to be an ordered pair. So negative 1 needs to get replaced up in that top equation. So I'm going to work that over here. Y is equal to 3 times x, or 3 times negative 1, plus 8. Negative 3 plus 8 is 5. So y is equal to 5. So in my ordered pair, final answer is negative 1, 5. Done. We're going to practice this a few more times here. C and D. So we know what y is. We got a 1 in standard form right here, the second one, and 1 in slope-intercept form. So slope-intercept form is going to go into standard form. So rewriting the standard form, 3x plus 4 times y, but we know that y is 2x plus 1, has to equal 26. Distributing my 4, 3x plus 8x plus 4 equals 26. Combining like terms, 11x plus 4 equals 26. Subtract 4 from both sides. 11x equals 22. Dividing both sides by 11, we get x equals 2. Well, then I need to go figure out what y is equal to. So y is equal to, up here, y is equal to 2 times x, or 2 times 2, plus 1. 4 plus 1 is 5. So y is equal to 5. So my ordered pair is 2, 5. Letter D, there's standard form and then slope-intercept form. Slope-intercept form goes into standard form. So standard form, starting writing that out, 5 times y. Well, y is 6x minus 4 equals 44. Distribute. 2x plus 30x minus 20 equals 44. Combining like terms, 32x minus 20 equals 44. Add 20. 32x equals 64. Now I have to divide both sides by 32. So I get x equals 2. Well, y, all the way back up here, put that in here, y is equal to 6 times x, or 6 times 2, minus 4. 6 times 2 is 12, minus 4, that will be 8. So my ordered pair is the solution to 8. All right, so now all of these have been pretty nice numbers. So these would have been okay to graph, but if we don't have a graph available, we can now solve them by algebraically substituting them in. So we look down here at these next two examples. They're a little different because neither one of them is in slope-intercept form. So we need to solve one of these for slope-intercept form, or just solve it for x. It doesn't matter. So I'm gonna solve. Well, they both kind of aren't very fun. So I'm gonna solve this one for y. So I'm going to work that over here. 2x minus y equals negative 4. I would subtract 2x from both sides. I get negative y equals negative 2x minus 4. To get rid of that negative y, I would either multiply or divide every term by negative 1. So y equals 2x plus 4. Now you have one in slope-intercept form that you could then plug into the standard form. So I'm just going to write here, slope-intercept into standard. Standard. And then get your ordered pair instead of reworking all of that. Okay, so this next one, neither one of these are x equals or y equals. This one would be pretty easy to get into y equals. So I would just subtract 2x from both sides. So y would equal negative 2x plus 8. So there's my slope-intercept form. So slope, I'm just going to abbreviate here, slope-intercept into standard, which then will give you an x, then go get your y, then write as an ordered pair. So I really abbreviated that because we've been doing that the whole lesson. But once you have a y equals or an x equals, you just plug it into the other one. So we actually have, for a different homework assignment, is a graphing page. So there's some substituting that you're going to graph the picture on the back. And then here's some fun facts about cows. Have a great day.